Welcome back, everybody. This is Ripley. All right, now we've got some terminology, we got some vocab, we got graphs, we know some brick and mortar terms like standard deviation and mean and how to find them. We got variance. Now we can start playing ball a little bit. Excuse me. I'm going to show you something here, but I'm going to make up some statistics. These may or may not be accurate. I'm sure they're relatively close. I'm going to say, let's talk about women's height. All right, and I'm going to make a claim here. I'm going to make a claim that women's heights are normally or bell-shaped distributed, and that they have a mean, a population, notice it's lowercase Greek, of, let's say, what's it, 5'6"? Is that fair? Ladies out there, yell at me if you think I'm wrong. 66 inches. And let's say that they have a standard deviation. So remember, we're talking population here of 2.5. And then we're going to have men's. I think the apostrophe goes in the other place, but I don't know. I'm no English guy. Men's heights. And let's see, I don't know, 6 foot, let's call it 70 inches. So we'll say about 5'10". That sounds about right for average, huh? 5'10", 5'11". Let's go 71 inches. But our heights are kind of all over the place. And we'll say that this is a little bigger of 4.5. All right? Now, I am 6'1", and my girlfriend is 5'8". All right, so my height, I am 6'1", so what's that give me? 73 inches. And my girlfriend, so GF, now this is a sample of one, so we're not getting fancy here, but we want to know who's got bigger bragging rights. What did I say? She's 5'8", so she's what, 68 inches? Okay. I want to know who's taller in their group. In other words, am I taller amongst men? Clearly I'm taller than the mean, and I'm taller than she is, but I want to know if I'm taller amongst men than she is amongst women. Okay? Now you're going to have to forgive me for a sec. I got to sneeze. And I'm, oh, wow. Everybody should say bless you. Come on, man. Say bless you. Okay, thank you. There's a fantastic tool, and it's so elegant and so easy to use. It's crazy. It's called a Z-score. This is a Z-score. Z-score. Sometimes you'll hear this referred to as the standardized score. And I'll try and discover what it gives us in just a sec. All right. What I'm going to do is the formula for a Z-score is either, if we're talking about a population, it's X minus X bar over S, or did I say population? Excuse me, sample. If we're talking about a population, then Z equals X minus mu over sigma. All right, notice that still just, these are the means, this X bar here, and this mu here are the means, and S and sigma are the standard deviations. So what I'm going to do is I'm going to find my girlfriend's Z-score, and I'm going to find my Z-score, and let's see if we can interpret what that means when everything is said and done. So this is going to be Z for the GF, and this is going to be 68 minus 66 divided by 2.5, which is what? 2.5ths, affectionately known as 0.8. My Z-score, so this is Z sub n, is Z sub m, is 73 minus 71 over 4.5, which is 4.5ths, which is what, 4/9, so 0.444. Now, let's look at what this really is, because this number is pretty, I should probably put an equal sign there, speak the language of math, right? What this represents is that my girlfriend's, I'm going to change colors, my girlfriend's height is 0.8 standard deviations from the mean. In other words, within the population of women, her height is is exactly 0.8 standard deviations above the mean. Now, meanwhile, over here, apparently shorty, I am only 0.44 standard deviations. In my group, I'm 0.44 standard deviations above the mean in my group of men. from the mean. So who's taller amongst her group? Well, as she will probably argue, it's her. All right? So that's a wonderful way to compare groups that have different means and different standard deviations. You know what I mean? It's, no pun intended. I mean, clearly, I'm taller than she is, but relatively speaking, if I'm looking for relative standing, she's much taller in her group than I am in my group. That's pretty cool, huh? Right on. All right. Well, we're talking about standing, like comparative standing. Something needs to be addressed because you see this in all statistics books, and you guys see it all the time, of course. We're talking about percentiles. So if I talk about percentiles, and the easiest way to describe it, percentile, if you haven't seen it before, let's say that I'm in the 90th percentile in height. This implies, so this is, wait, I don't want 90%. I want 90th. 90th, sorry about that, 90th percentile for height. This implies that 90% of everybody is shorter than I am. Okay? If I'm in the 32nd percentile, 32nd percentile for IQ. IQ, this implies that 32% of everybody is dumber. That's not the politically correct way to say it. Let's try that away. Try that another way. Has lower IQ. Has lower IQ. However, conversely, if you think about that, that also implies that what? 68%? 68, I'm missing an 8 in there. Whoops. 68% of everybody has a higher IQ. So you can read it both ways. Okay? So you've seen percentiles before. The easiest way to figure out what percentile a data value is you simply take, you let x equal the number of data values below a certain value. Okay, and you take x divided by n. Remember, n is the total number, whoa, my pen's starting to get a little crazy. Total number of data, and then you multiply it times 100%, and that gives you your percentile. This is equal to percentile. Okay? All right. Now, there's a statistical tool lately called a box plot or a box and whisker plot. All right? And you may have seen this before. And these guys look like this. What you'll get is you'll get a box, and then you'll get a value inside the box, and then you'll get something that looks, I don't know, maybe like this. And then down here will be numbers. This is, by the way, called box plots. Okay? Now, you'll have numbers down here. So let's say that this is 1, and this is 5, and this is 12. I'm just completely making these up. Clearly, my scale is a little bit janky, so bear with me. Let's call this 18, and let's call this 25. What we're looking at in a box plot is real simple. All right? We're looking at the minimum value of the data set. That is on the left. This would be the maximum value of the data set. That's on the right. Now, this is called Q1, or the first quartile. The first quartile represents the 25th percentile. Okay? This guy right here, as you can well imagine, I'm going to change pen colors on this so you can see it. This is the median. All right? If you think about it, the median represents the 50th percentile. Okay? And then over here, we'll change back to black. This guy over here this is Q3, which is the third quartile It's crazy because they use all these different names for the same thing. This is the third quartile or the 75th percentile. Okay? So this group of numbers, the min, Q1, the median, Q2, or excuse me, Q3, and the max is called the 5-number summary. 5-number summary. And it is what is used to build a box plot. Now, I want you to notice something about a box plot. I have no idea what n is. I have no idea how big my sample is that created this box plot. Not a clue. I don't have a clue. But I do know what the min, the first quartile, the median, the third quartile. You could also think of the median as being Q2, sort of parenthetically speaking. If we wanted to think of it as Q2, we could. With Q3 and what the max are. All right, now I'm going to show you the power of a box plot here in just a second. But what I'd like to do first is I want to take you through a quick and down and dirty little way to make a box plot and a 5-number summary. And again, you'll be able to do this on your calculators. It'll spit all the values out for you, and it'll actually give you the box plot as well. But let's go through it by hand. Let's get an appreciation for what it does, and hopefully you'll see what happens. Okay? All right.